Hello everyone. Hope you are all in best of your health. Stay home, stay safe. This video will cover the first chapter of third module. In this video class, you will learn about the basic concepts of embedded system. At first, we will define what an embedded system is. We will also go through the definition of general computing systems. Once we understand the basics of embedded systems and general computing, we will differentiate them depending on their functionalities. We will also look back in time to understand the history and evolution of embedded systems. Then we will dive deep into the classification of embedded systems. We will understand how different classifications are made, taking different aspects into considerations. We will also glance into major application areas of embedded systems. At last, we will understand in what context the embedded systems are used in our day-to-day life. So let's start the chapter. Starting from the basic, we can define embedded system as a hardware system having software embedded into it. An embedded system is a microcontroller or a microprocessor based system which is designed to perform specific tasks having washing machine, radio, TV as day-to-day examples. If embedded system consists of hardware and software, then how can I define a computer that I am using? Hence, general purpose computers are built to have customizable software to perform various tasks. There is no constraints on power, performance, or cost unlike embedded systems. So, what are the general differences between general purpose computers and embedded systems? Here is the list of differences that you can go through. In general purpose computers, microprocessor acts as a main processing unit, whereas in embedded system, microcontroller acts as a main processing unit. General purpose computers have general purpose operating system, whereas embedded system may or may not have an operating system. General purpose computers can be used for different purposes, whereas embedded systems are designed for specific purpose. General purpose computers are costlier compared to embedded systems. Now let's dive deep into some historical events that are very important in the field of embedded system. In 1960, for the first time, embedded system was used in Apollo guiding system. In 1968, automobiles started using embedded system. First microcontroller was developed by Texas Instruments in 1971. Windows released its operating system for embedded system called Windows CE in 1996. Embedded system market reached $140 billion in 2030. Now let us understand how an embedded systems are classified. Embedded systems are classified mainly based on generation, complexity and performance, on deterministic behavior, and on triggering. In this class, we will mainly concentrate on classification based on generations and complexity and performance. Now let's see how embedded system is classified based on generation. The classification is based on in order which the embedded system evolved. We have four generations. We can see the classification on your right side. Clipart on every generation slide represents an embedded system example of that generation. In first generation, embedded system was built around 8-bit microprocessor and microcontroller. Software and hardware were both simple in nature. Digital telephone keypads can be considered as example for first generation embedded system. In second generation, embedded systems were built on 16-bit microprocessor and 8 or 16-bit microcontroller. They were more complex in comparison with generation of 1 embedded system. Few second generation embedded system contained operating system. Best example of second generation embedded system are SCADA systems used in industries. Third generation embedded systems were built around 32-bit microprocessor and 16-bit microcontroller. Concepts like DSP and ASICs were evolved in this generation. Robotics machineries can be considered as an example for third generation embedded system. In fourth generation embedded systems, they are built on 64-bit microprocessor or 32-bit microcontroller. System on chips were introduced in fourth generations. Your handheld devices can be categorized into fourth generation embedded systems. Now let us see how embedded systems are categorized on complexity and performances. In this category, embedded systems are classified as small scale, medium scale, and large scale embedded systems. In small scale embedded systems are simple in nature. Performance is not time critical. They are built upon 8 or 16-bit microcontrollers. An electronic toy can be categorized as small scale embedded system product. In medium scale embedded systems, these are slightly complex in nature accordance with hardware and software built on 16 or 32-bit microprocessor or microcontroller. Industrial machines are best examples of medium scale embedded systems. Large scale embedded systems are highly advanced and have complex hardware and firmware. These are built on 32-bit or 64-bit RISC microprocessor or microcontroller. They can even consist of multi-core processors. The main purpose of this high complexity is to perform time-critical actions. Your ATM and vending machines are large-scale embedded systems. In the next video lecture, we will cover the remaining part of the chapter. Thank you.